Hi everyone, welcome to lecture 20 of your electric circuit class. And lecture 20 is about RC circuits. The objectives of this lecture, the first thing you need to know or understand why RC circuits are called first order circuits. The second objective is to understand time constant and how to find it for RC circuit. The third objective is to determine voltages and currents in RC circuits. And the last objective is to distinguish between switch closing and the switch opening. So RC circuits. The first thing that we should know that capacitor do not charge or discharge instantaneously. Instead, voltages and currents take time to reach their new values. Second thing, the time constant is tau is equal to R Thevenin times C. This over here is time constant in seconds. This over here, R Thevenin, that is the equivalent resistance of the circuit looking from the capacitor. And this over here is the capacitance in farad. It takes 5 time constants for a capacitor to reach 99% of the final value. What we mean by that, to reach steady state. So usually the response of a voltage or a current, if the capacitor is charging, it will look like this. So now if you look at that at this point on, it will be, let's say, steady state. And this portion over here, the whole thing over here, this is the transient time. Why is that? Because the value of our voltage or current is increasing exponentially, and it takes 5 time constants, which is 5 tau, to reach this value, which is like almost the steady state value. And also RC circuits are called first order circuits due to the presence of one storage element, and in this case it is a capacitance. So its response can be represented by a first order differential equation. That's why. You remember that we have, for example, the current in a capacitor, that is C dV over dt. So if you look at that, this is first order differential equation. So what about the switches? We have a switch may look like this. This is a switch. So now if the switch action is going this way, and we are saying that t is equal to 0, this drawing over here, it means that a switch was open and then closes at t is equal to 0. If we have a switch like this, then that means the switch was closed and opens at t is equal to 0. If we have a switch like this, this is, let's say, A and this is B, it means that switch what? Was at position A and moves to position B. That is the meaning of this. So If the drawing is over here like that, that means this side over here, it's gonna move all the way up to here. Now, if I have it like this, that means this over here, it's gonna move from A to B. Okay, from A to B. All right, so now we know the switch actions. So now how we can, let's say, solve for an RC circuit if we are required to find a current or voltage. So we can say that step by step analysis approach. The first step over here, we just assume a solution of the form x of t is equal to x of infinity plus x of 0 plus minus x of infinity multiplied by the exponential of negative t over tau. Negative t over tau. And this is for t greater than 0. So if the requirement, so if the question is asking about voltage, then V of t is equal to x is equal to V of infinity plus V of 0 plus minus V of infinity exponential of negative t over tau. And if the question is asking about current, then I of t is equal to I of infinity plus I of 0 plus minus I of infinity multiplied by exponential of negative t over tau. That is the first step, so we assume the solution. The second step is to draw the circuit before switch action, replace capacitor by an open circuit, and find the voltage across the opening. That means we are going to get VC of 0 minus. That is at the instant before the switch action. So over here, please note regardless of the requirement in the problem, this step is to find the voltage across the capacitor when it is open. Step number 3, draw the circuit after switch action. Replace the open circuit by a voltage source with a value as obtained in step 2. That means our VC of 0 plus is equal to VC of 0 minus, because we have said that it will not change abruptly. And then after you do this, we need to find X of 0 plus. Step number 4. For the circuit in step 3, open the voltage source, which is the one that replaced the capacitor, and find X of infinity. Number 5, find R Thevenin across the opening. Number 6, find the time constant tau. Number 7, evaluate or substitute step 1. Then that will be the solution. Let's go over an example to show you the implementation or how to apply, let's say, these steps. Suppose that we do need to find V naught of t for t greater than 0 for this circuit. This is for K, 50 microfarad, 2K, for K, 24 volts, 2K, 12 volts. So over here, if you can see that the switch was open, then closes at t is equal to 0. So that means open before switch action, and then closed, which is after switch action. Solution. So if you look at the question here, we are saying that V naught of t, this is what we need to find, which is this voltage over here. So the first step, we need to assume a solution of this form. V naught of t is equal to V naught of infinity plus V naught of 0 plus minus V naught of infinity multiplied by exponential of negative t over tau. So from this here, we have the steps to find our V naught of infinity, to find our V naught of 0 plus, and to find our tau. So this is our first step. The second step, we need to draw the circuit before switch action, replace C by open circuit, and then find VC of 0 minus. So this is what we will do. So our circuit will look like this. This is where our capacitor, so I will open that, plus minus, this is VC of 0 minus across the opening. This is 2K. Over here we have 24 volts. We have 4K here. We have 4K here. So our switch is open. So since this is open before switch action, it's open, then the whole thing here will not affect anything. So we can just take it away. So now, for our VC of 0 minus, that is equal to 24 volts. The reason, because there is no any current flowing. That means if I put a voltmeter at this point and at this point, and I want to measure, that is voltmeter, and I want to measure the voltage across this opening, it will give me that 24 volt value. So that is step 2. Now we will go to step 3. Step 3, it's saying that draw the circuit after switch action, replace the opening with a voltage source with VC of 0 minus value, because VC of 0 plus is equal to VC of 0 minus, since the voltage will not change right away, so it will not change abruptly. It takes time. So the instant before switch action and the instant after the switch action for the voltage, that they will be equal. And then find V naught of 0 plus. So this is our circuit here. We'll draw the circuit. So this is 2K, 4K. This is where we need to find V naught of 0 plus. This is 4K, 24 volts. And this is a voltage source that we just found in step number 2, which is 24 volts. And the switch, it is at this location, and we closed it. So when we close this, this is how it will look like, just a short. And then we have 2K, and then we have 12 volts. So if I go with loop analysis, I can assign loop 1 over here, that is I1, and I can assign loop 2 over here, I2. And please pay attention that the way that we assign the loops are, the direction of these currents are counterclockwise. So loop 1, negative 24 plus 2I1 plus 24 plus 4I1 plus 4I1 minus I2, that is equal to 0. Okay, then this will give us 10I1 minus 4I2 is equal to 0. That is our first equation. Now we go to loop 2. Loop 2 is 24 plus 4I2 minus I1 minus 12 plus 2I2 is equal to 0. Collect the terms, we get negative 4I1 plus 6I2 is equal negative 12. And this is our second equation. Now we can solve these two equations by putting them in the top of each other. Negative 12. Then if I multiply this by 1.5 and I add them, we will get 11I1 is equal negative 12. And from that, I1 is equal negative 12 over 11. So from this, our V naught of 0 plus is equal to the 4 kilo ohm resistor times I1, which is equal to negative 48 over 11, which is equal to negative 4.36 volts. And this is V naught of 0 plus. Now we go to step number 4. Step 4, we said that draw the circuit in step 3 with the voltage source VC of 0 plus open, and find V naught of infinity. So this is what we will do in this step. So now this is our circuit. and this is open, plus minus, this is V naught of infinity, so now if you look at this here, since this is open, there is no current flowing. And when there is no current flowing into or through this resistor, that means the voltage is zero. So V naught of infinity is equal to 0 volt. Step 5. Step 5, we need to find R Thevenin. So it is the same circuit. $2K, 4K, 2K, 4K. And this is where we need to find R Thevenin, which is looking at the whole circuit from the place of the capacitor. So of course that to find this R Thevenin, we need to look at the circuit. So the circuit here, the circuit has only independent sources. Then we can use the reduction method. And we need to turn off all sources. So if you look at that, we can say 2 parallel with 4 plus 2 plus 4. So these two resistors are in parallel, and the combination in series with this resistance and that resistance. And that will be 8 over 6 plus 6, which is equal to 44 over 6, and that is equal to 7.33 kilo ohm. And this is our R Thevenin. That is step number 5. Now step number 6, find tau. We said that for RC circuit, tau is equal to R Thevenin times C. So R Thevenin is 7.33 times 10 to negative 2 positive 3, because it's kilo ohm, multiplied by C, which is 50 micro, that is 50 times 10 to negative 6. And then our tau in this case is equal to 0.366 seconds. Now step 7. Step 7 is evaluating step 1. So when we evaluate step number 1, that is V naught of t is equal to V naught of infinity plus V naught of 0 plus minus V naught of infinity multiplied by exponential of negative t over tau. So now this is equal to V naught of infinity, which is 0, plus V naught of 0 plus, it is here, negative 4.36. Negative 4.36 minus 0 exponential of negative t over 0.366, and that is equal to negative 4.36 exponential of negative t over 0.366, which is negative 4.36 exponential of negative 2.732t. Because if you look at this here, when we are saying negative t over 0.366, that is really equal to 1 over 0.366, and it is negative times t. So that is from where we got the value over here, which is negative 2.732 t. And that is, of course, in volts. And this is our response. That is the response of V naught in our circuit after the switch action, which is t greater than 0. By this, the lecture is done for today. As long as you know switch action, RC circuits, they are first order circuits. Tau is equal to R Thevenin times C for RC circuits. And use the 7 steps approach to solve for currents and voltages. You will be in good shape. And this is our homework.